That's what I'm... Thanks, Dave. Do I look like I know what a JPEG is? Just want a picture of a goddamn hot dog.
Alright, it's doing much better.
Sick.
Let's send it.
Alright, let's get this commencement beginulated. Cool. Alright. Cameras A and B mark. Okay. I joined Team 190 in Massachusetts back in the fall of 2005. So I did 2 years with them because it's a 2-year high school. We won the championship in 2007. Evan and I. It was super cool. And then I immediately started mentoring as soon as I graduated. And now, well, last November I took a job with Overdrive Specialties. That moved me out here, and then I started mentoring Jack in the Bot. And I realized that there's sort of a disconnect in when I'm talking about previous games and previous robots and previous architectures. There's all this knowledge in my head. I've seen all these things, but trying to describe everything can be difficult without like a foundation of like why teams did that that year. What were they trying? What problems were they trying to solve, and what resources were available for them? It's mostly just going to be a presentation, especially with the shortness of time. But if you have questions, every 5 games or so, there'll be a sort of era recap. We're not going to get into the subject of which things define which eras, but maybe field a couple of questions then. So, before 2005, FRC's games were varied and different, and they had kind of coalesced into alliances by 1999, but it was still 2 versus 2 up until 2005. And every game since then, you can pretty much directly compare them because it is 3 robots against 3 robots. So the first year of this, and all the fields are pretty much the same size, and they're covered by carpet. So tetrahedrons made out of vertices and the lines between them littered the field. There were 9 of them. In the corners and the middle and like the center of the field were the scoring areas. There were these like 6 foot tall, and the middle one was like 9 feet tall. And you put on top of them tetrahedrons made out of PVC pipes. And that was one of the years where you made your own game pieces for the game. Like you had to cut out the thing that would connect them in the corner. They called it the clover, and that was really difficult for some teams. But then you just made the game pieces as many as you wanted. And those things weighed 13 pounds each because it's like thick wall PVC pipe. So the object of the game was you would get like 3 points for every tetra that you scored. But if your alliance's tetras were on top, so you could stack them on top of each other. If your alliance's tetras were on top, then you owned that scoring thing. And if you could get them in rows and columns, and you could like tic-tac-toe it, and you would get a bonus for each row or column that you had, or diagonal. So if you controlled all 9, your opponents were getting very, very, very few points. So you were fighting these. As you scored, your opponent would try to take away the row that you just made. So on this field, there's also one really important thing on here. These little red triangles and blue triangles, the loading zones, your human player stood on a little pad, and the pad, when you stepped off, it was a pressure pad. When you stepped off the pad, your robot lost all contact with the field. It would be disabled while you were running out there with a tetra to put it onto your robot. And then you'd run back, and when you touched it again, your robot could drive away. Or there were these automatic loading stations, which field resetters were like resetting, so you could just go over and grab them. But if your robot was in the loading zone, like if you were covering any part of that triangle, it was like a plastic triangle that was on the field, and your opponents touched you, they got a 30-point penalty. And all of the games up until 2012, penalties decremented your own score. And looking at the the available scoring things you could do, it was 10 per row or 3 per tetra. So, especially with how many things teams actually scored back then, if you got one of those loading zone penalties, you probably just lost the match. You probably had like a 0 score. So, very high swings there. But because you didn't know how tall it could be, you could just keep stacking on the same one, and the height would change as you kept going. So, you had to have some sort of arm or elevator to do it. And arms were sort of the meta back then. Not a lot of certainly not any belt driven elevators, but big weird linkage arms like 67 had. 330 had a simple shoulder joint thing, and the manipulator to actually control the game piece was like a stick. You just had a stick with a post behind it, and it would your kid would put it on the stick, and then it wouldn't slide past the post, and that was it. And then you would gently sort of lay it on top of the tetrahedron, and that's how everybody scored. No active manipulators. You would just like stick something in through the tetra, put it on top of the thing, and then drive away, and that's how you scored. So there's a lot of arms. This was one of the first years that Pink had the really low pivot elevator inside the extension thing, and you could hold as many tetrahedrons as you wanted, but the resetting, like the human player could only have one tetra at a time to run out. So they'd have to run out, put it on, run back, all of this. So kind of balancing, we could have a bunch on our robot and just score them one by one versus how many are you actually going to score during the match, when the answer is like 5 if you're really good. It was generally better. The alliances that succeeded were mostly robots that just held one at a time. So big, weird, like double jointed arms or single jointed arms or pink arms back in 2005. And 2006 was like the opposite kind of game. So it was the first real shooting game. On top of the Alliance station was a 2.5 foot wide opening for you to score. You would score away from yourself, over your opponents where they were driving. And you could hold an unlimited number of poof balls, like foam, multicolored balls. There were 120 on the field. And the match was broken down into auto, and then offense, defense, and then both offense. So you would score in auto, and the field was not divided during autonomous. You could just have your autonomous go and like drive into your opponent robot and make it so that they missed. It was defense and autonomous back then. And if you won autonomous, you would get not only a 10-point bonus, but you would also start the first period for you would be defense and your opponents would be on offense. So theoretically, if you were both shooting at the goals in auto, and then you scored more than they did, you'd get the 10-point bonus, and they would immediately go on to offense mode, and they would have shot all the ones that they started with. Everybody could start with up to 10 balls. Rate of fire wasn't super fast back then. It was also limited. One of the rules was the maximum velocity that you could eject a poof ball from your robot was like 12 meters per second. This was somewhat adhered to, but it was a limitation on it. The bigger problem largely is just an open field with ramps on the end, and you at the end of the match drove onto your own ramp to score points, and that increased by the number of robots. It wasn't just flat bonus. You would get more the more robots that were on it, but you were scoring balls away from you and then ramps towards yourself, and you started on the sides of the field, which is kind of weird. But the bigger problem was poof ball management. These things stuck together like crazy. If you put them next to each other and tried to get them to go through a hole, they would not do it. So you wanted to get them into single file somehow and get it into a shooter. Most teams that tried to score in the high goal were doing shooters. They weren't doing catapults. There were a couple of really funky catapults back then. But one of the options was don't pick up from the floor, what 25 did. I should mention, best robot is kind of a very loose thing. It's very hard to evaluate that, and it is indexed a little bit more toward teams that had success at championships. But it might also be archetypes a good example of like the best kind of way to solve the problem in that year's game. It could also just be this was something that a lot of teams adapted later on. But they didn't have a floor pickup. They could just throw the balls in from their human player directly into this weird little hopper that they had. And that whole thing was a turret. And they had great accuracy because they had a weird carriage thing that brought the ball toward their huge shooter wheel. And the object ball, as it was leaving their robot, was in contact with the shooter wheel for like 150 or more degrees. So a lot of time for the energy to transfer into the ball. Other robots took a different tack. 254 and 968 used to make they used to make clones of each other during the build season, and that was floor pickup into a big sort of random hopper, and then they would pull it with polycord belts into a shooter up at the top. Fixed hood, fixed direction. They just changed the angle of the robot. But what they discovered, and a lot of teams discovered, was you could drive up onto your opponent's ramp because you couldn't extend above a certain height. Your robot, you weren't allowed to extend up. You could extend out a little bit, but nobody did it. But if you got up onto the ramp, then you were like 2 feet below this goal and right in front of it. And so you could just sit there and shoot the balls that were in your robot, and if you missed, they would mostly, or some of them would return back into your robot. And 71, who is also extremely good, they had a swerve drive and a similar thing. So in terms of like the finals matches had scores near the 100-point mark, but this was at IRI. So if you look at the far side of the field here, 11, 14, and 33 are both very good robots. They're shooting into the red goal. And that's about the rate of fire that like a very good, that's pauses in the video. That's a rate of fire that like very good shooting robots did. Now 71 is moving their way onto their opponent's ramp just before the match changes from red offense to both sides offense. And there's like a huge whistle sound, and incidentally, if you watch this match, there are 2 game announcers both trying to announce. It's kind of weird, but they inundate this thing. And there's just one ramp on this behind it with like a very shallow shelf that all the balls could get on. And the pokey stick guy, they're trying their darndest because this is the most balls that were like ever in a goal this year. This match ended up being, it was 133 to 137, and it was a very unexpected sort of like offensive firepower compared to what you saw for most of that. You would have the opportunity to recycle. Your opponents would return the balls that you scored back onto the field of play, but generally, if you had like a big hopper and you could actually get balls through, you'd shoot once, maybe twice. Teams were not super good back then. You had to design all your own gearboxes to control everything. The available motors. 2005 was the first year that you had 4 sims in the kit. Before that, you didn't have 4 of the same high-powered motor. So it was difficult to do like a lot of independent module anything for drive or for anything else. You'd be sacrificing some of your higher power motors. So everybody was pretty much just 2 sims on a side, tank drive. That was what everybody did like forever. Rack and Roll, again, was a pick and place game. There was a big central goal with 24 places to score on it. 3 rows of 8 around. And the scoring wasn't linear. It was the number of tubes in a row is n, where 2 to the n is your score. So 2 in a row is 4, 3 in a row is 8, 16, 32, etc. And it wasn't infinite if you went all the way around. It was just 256. And then you would also, at the end of the match, you would be evaluated if any robot that was above 4 inches off the ground was worth 15 points. And any robot that was above 12 inches off the ground was worth 30. So everybody made some sort of ramp structure thing that the other robots would drive on at the end, and that was where some teams got the majority of their points. But where you placed your tubes, these were inner tubes. These were toroidal, like big donuts that you'd put on the central rack. And autonomous, very few teams were able to do it because the vision processing was not up to snuff. And they spun the rack before the match, so the place that you scored would be slightly different. they had 4 vision targets around the perimeter of the top of the central rack. And before the match, the referees would go out and spin the rack so it would be in a different position. So wherever you scored your opponents, that affected where your opponents had to score next, because you were either trying to make it like a really long run, or you were trying to stop them from making a really long run to get the points high or low going into the end game, because either you had great ramps or you didn't, or your strategy wasn't about that. So so to get 2 robots on top of your robot was no easy task, and 1114 had quite the robot to try to do it. It had to deploy in such a way because you needed width and you needed length and you needed some sort of stable thing for teams to drive on, and then they winched it up. That whole unfolding sequence somehow pulled with 1 pin to do that. And then also, you had a flagpole. Bumpers weren't mandatory. You could just not have bumpers on your robot. So the way that your robot indicated which alliance it was on was you had a flag with red or blue on it, and the flagpole had to be upright. So that's why right at the end of this video, you see that the flagpole has to like swing back to upright. But the other things that really worked for teams were static ramps.
Okay,
They just folded down and they sat there, and teams could drive on them.
Yeah.
And this was in your home zone, so it was right in front of your driver's station. And you didn't get to select your driver's station in playoffs back then. It was just assigned by your captain, first and second pick. So generally, it was a little bit nicer to try to drive toward the station rather than try to drive toward the center, but you're still working with a different perspective thing. So a lot of fixed ramps, that's 33, but 71 had similar ones. The team I was on, 190, had very different articulated ramps that came out to the side, so the teams had to come to the corners of the field and drive up toward the center, and then we actuated them to push them up. So if you drove up and we left the ramp as it was, we had a spike strip that would stop the back of your robot from going below 4 inches off the ground. But if you got up far enough, when we fired the pistons, it would tip you up and get you above 12 inches. And so the strategy that our alliance employed was we really indexed on the ramps. We said we want a lot of bonus points, so we don't want a lot of points on the rack. We don't want a lot of tube score. So wherever our opponents were scoring, we just scored next to them. We weren't trying to make long rows of things. We were just trying to keep their points all the way down. So the final match 3 on Einstein, the rack score, almost all the way filled, was 14 to 24. Just like nothing. The bonus points were 15 or 30. Like we were trying to get 60 points with our ramps at the end of the match. And the rack had 14 and 24 points. So you could really tweak the game toward which would work with your alliance. Lots of elevators in this game, fewer arms. 33 had a really weird like flip out wrist thing with an arm. When teams were trying to get a tube scoring mechanism in between like 2 big ramp structures, you had to get really creative with the spacing and utilization of like small materials to get them to fit in just the space that you had. All these robots were a drive base. You were inspected to have a drive base that was less than 28 inches by 38 inches, which is a perimeter that when they changed over later, it became about 85% that size. So robots are now much smaller than they were back in these days. 2008 Overdrive, again, a very different game from 2007. The field was set up into 4 quadrants with a wall in the middle. And you had to drive anti-clockwise around it. And every time you lapped the field, you got 2 points. And if you had a trackball and you threw it over the overpass, which was a ladder across the center of the field, that was worth 8 points. And then in auto, every line you crossed, there were 4 lines. So a lap would be 4 lines in teleop. But in auto, each quadrant that you got into was worth 4 points. So you could get beaucoup points just by having a really good autonomous mode, which they called hybrid mode because you could have you could technically control your robot with up to 4 individual commands that year. Is weird. And if you placed, so the trackballs, which were huge, 40-inch diameter inflated balls with nylon covers around them. So they started on the overpass, randomized which bay they were in, up to 3. So there'd be a red and blue on each side, but you didn't know where they'd be. So at the start of the match, you would start in front of your player stations on the right side of the field for you. And the lane divider was like a polycarbonate and metal structure. You couldn't pass through it. So you had to go around in a circle, in a big oval. And if you knocked the trackballs off the overpass in auto, they were worth 12 points to do that. And at the end of the match, if you placed them back on top of the overpass, that was also worth 12 points. So it was more than if you just hurdled, if you just threw it over and hurdled it. So a lot of teams made elevators and big arms to try to get the trackball down or to put the trackball up at the end. But 11-14 got right to the heart of the matter, and they said, why don't we just go around the field way faster than everybody else, pick up the ball with a roller claw. This was there weren't very many roller claws in 2007. Single-digit number of really good teams used them. It was those motors that you couldn't afford to put into a system like that. But 11-14 said, instead of having any value in placing the trackball at the end of the match, we will just pick it up better than anybody else, get it over the overpass better than anybody else, and have our hybrid mode, our autonomous mode, so far ahead of the pack. They were like standard deviations above other teams in terms of scoring. They're super, super good. But everybody who could drive around the field really fast and pick up the ball with some level of control was really good. And some of them were arms, but a lot of them, like Rush, had a big top roller thing, and it would get into there, and then they would articulate the top of that thing back somehow, and a winched up catapult thing would launch it. And 11-14's was a puncher. It was stored energy, and then just behind the ball they would release it and it would just shoot it straight out. So it wasn't like a wheeled shooter. It would collect it in and then it would punch it really hard. 16 that year had something that was thereafter banned, but kind of it would show up every couple of years. Back in the day, it was a flop bot. So it would start the match against the Alliance Station wall, standing up. The base would be standing up. Their wheels wouldn't be on the ground. Because then they would drive with their collector roller on the carpet and pull their robot down. And that gave them, because the way that you did your starting configuration, it was 28 by 38 by 60. So they just made it so that their base was 60 inches long and 38 inches wide. So now this 40-inch diameter ball doesn't look quite so bad. So they just had this huge boat, and it was, again, a catapult. But in terms of arms, one of the designs that really captured everybody was what 121 put out, because they put out a video of this week 3 of the season with them just hurdling, just practicing with this thing. And so it's a roller intake on top, and then the arm is just a shoulder joint. So they would drive around, and then they'd turn. They would have to spin in place, and they would lift it up over and pinch it with the claw to get it out of the roller intake over the thing. And it was a 10-pound 40-inch trackball. So this was a thing that could do it. So there were 3 or 4 clones that just came from. They saw it and they said, we have been in the wilderness. We have no idea how to get this ball up over this overpass. Here's an idea that's going to work, really torquey shoulder joint and roll a claw and then just squeeze it out of there. And it was very, very, very good. So these were the last of the games that used the old robot architecture. So the driver station and the robot brain were both made by IFI. Is very basic, some years P basic, PIC processor, solid state, very low amount of data that could be fit on it. In 2005, 190 tried to have the floating point math to run mechanism wheels and camera code, just any vision code. And they could not fit both of those things onto the robot. Not enough space. And this was controls and sensors. You could improve little things on robots, but they weren't the difference makers. It was really that the teams that were super good had good mechanical engineering and good manufacturing capability. They could make what they were trying to make, and they could make gearboxes that made sense, that didn't blow up, that didn't smoke motors. And this was all regionals, and First has grown in number of teams and stuff. In 2005, including the championship, there were 31 events. So still 6 weeks of competition season, but 5 events a weekend. Lunacy, brand new control system. So a bunch of new components, new power distribution panel, new robot brain, new driver station. The driver station was actually just a PCB inside of a metal box with no electrostatic protection on it. This became an issue because the game, so they had the carpet down, and then on top of it, they put down fiberglass reinforced plastic, which is like what's on the walls of grocery store bathrooms. It's textured like orange peel, they call it. It's just a hard plastic thing. And to make it work, well, the idea was instead of making it a game about pushing, it was a game about not pushing. So on top of this, the regolith, which is what they called the plastic, you had to drive, and your only point of contact with the field could be these hard plastic wheels. So you had a coefficient of friction of like 0.15 instead of the almost 1 that we see nowadays with modern tread and Coulsons and things. So an unfortunate side effect of teams trying to drive with hard plastic on hard plastic is that's a Van de Graaff generator. It generates static electricity, and this was a brand new control system. So they would generate a lot of static electricity. They would run into the wall, and the electricity would go into the quick bite, into the driver station, and blow up the Ethernet ports. So there were that and other things made it sort of a rocky beginning for the new National Instruments Creo control system. You also had to take the Ethernet cable that was going from the radio to the C-Rio out to plug in your laptop to put new code in. You couldn't do switches. So lots of teams put their robot out on the field with the radio not connected to their robot. It was a big learning curve. But the game itself, so that was the only way that you could drive around. And the game pieces were these woven plastic netting balls. It was like 5 or 6 bands of just thin plastic covered with a thin like nylon sort of fabric. And they were called moon rocks. They acted like balls. They just didn't have a center in them. So there were scumpty-ump balls that you could get. Your robot could start with 7, and it was 120 balls, plus a couple. There were a couple weird balls. So every moon rock, those were the regular ones. Those were worth 2 points. And then there were empty cells, which the kids in the center human player stations. So these kids, the red and the blue on the sides of the field, they're not standing. They're sitting in a seat with a seatbelt. And that's where they're launching from. And there's a polycarbonate shield between them and the robots. And also a hole. But you could take an empty cell from the center stations and bring it to your human player stations on the corners of the field. And they could exchange the empty cell for a supercell. And that ball was worth 15 points. But you could only throw that in the last 20 seconds of the match. These were basically never relevant because that sequence of events, unlikely. You had to somehow coordinate picking up this one special ball and then delivering it not into... Okay, so the central scoring area, the actual place where you were trying to score in this game, was your opponent's. So in addition to the wheels that you were driving around on, you had to drag behind you a trailer, a mobile goal that was hard connected to your robot with a little trailer hitch thing. And it was the same plastic wheels, and it was like a cage of... you can see it in the back of this picture with 217. So a ringed cage of PVC pipes with a PVC pipe in the middle. And you would drive around and try to keep your opponents from scoring in yours while you tried to score in theirs, and it was this Ouroboros of driving around the field and slowly getting your way kind of near something. So you could do vision, you could try to track the trailers. But the vision target was a translucent piece of plastic with nylon fabric around it. You can just see the bottom of it just below 27, just at the back of this picture with 217. And it was pink and green. And if it was red, pink was on top. And if it was blue, green was on top. So you're looking at a non-illuminated target with your camera. And the Georgia Dome, which is where they used to have championship, has a translucent roof. So the lighting conditions would change match to match if it was cloudy. It was impossible to calibrate. Teams did not do like a whole lot of vision targeting in this. So your human players could throw the balls that they had throughout the match, and your robots would go around and try to score balls into your opponent's trailers, all of these things. There would be moon rocks scattered all over the place, so lots of teams picked up from the floor. There weren't very many robots that did especially well with just human loading. Although there were strategies later to directly human load rather than if your human player missed, you would then try to go eventually pick it up. There were teams that in Autonomous would just drive over to where their human player was and had them roll them into their robots because it was you would not often get an opportunity to like really be right next to your opponent's trailer with a huge hopper full of balls. So when you did that, you wanted to have the most that you could and stay in contact with them and just drive doing it. So you wanted a wide drive base rather than, so your 38 would be the wide dimension because this gave you the most ability to turn, which, I mean, you're skidding wheels and you're trying to do traction control so that they don't skid so much, but you only do what you can. And one of the things that separated some of the teams at the absolute top after they'd done all of the traction control stuff and all of the other things was they put big fans, like big propeller fans in cages on the back of their robots so that when they were driving forward, they would have the fan running and they would have more thrust. This made an appreciable difference in how robots were able to move around the field. And also all the field side volunteers appreciated that because they got the breeze. But we saw some teams do like an Archimedes screw sort of thing. So the center column of 217's robot here, that spins and there's just a ramp that all the balls go on. So they enter the robot in single file and they leave in single file. So they have a turret on top of that. But the other conceptually simpler and in a lot of cases more effective design was get all the balls above the height of the trailer where you could score in somehow, and then just drive right next to the thing and dump them out. There was not a lot of ranged scoring in this game, and so Wild Stang that year 111 they had a swerve drive, and the bottom of this whole hopper that moved up to kind of force the balls through their shooting rollers at the end. But 2753 Overdrive that year, they were a rookie and they were on Einstein. And their robot had a conveyor belt. It picked up balls from the floor and it put them in a big just box at the top of their robot. And then they dumped them out. And they just drove really well. And human players scored more than half the balls at championships. 2009 was a very weird game. Don't watch the Einstein from that year. If you really want to go and find some good videos, not Einstein, because in divisional finals, those fields, the FRP, the regolith, that had been driven on for a couple of days. So there were a bunch of new scratches in it. So teams had way more traction. But they put brand new stuff out on Einstein. And so everybody, all their traction control logic is just out the window. They're just sliding around. The 2009 Einstein is not a very rewarding watch. 2010, Breakaway. So goals in the corners of the field, and the object ball was a soccer ball. You could hold one at a time, and because they didn't want a game similar to 2009 where you pulled the ball in and then you could manipulate it however you wanted, you could only bring it into your robot up to 3 inches. So you had to somehow convince the ball to stay with you because that's before the center of it. So the initial rule as written was your collector could not pick the ball up off the ground. It had to be in contact with the carpet. And there was some question as to whether that was in all situations or just in practice, like on the field. So eventually it got to the point where everybody was making like pinch grippers, like a bar on the top and the bottom to hold the ball in, because every other kind of collector just didn't work. Except for suction. Suction kind of worked. But if you just had a top bar, yeah, it would roll with you most of the time, but if you drove too fast, it would just roll away from you. And then at the end of the match, you could suspend your, well, if your robot was only in contact with this structure, you got 2 points. Every soccer ball that you scored was worth 1 point. So these bumps, they were called bumps, divided the field. You could only have one defender in your home zone, the one with your 2 goals that your opponents were scoring on. That way you couldn't just like block both of them and just call it a day. So the balls would recycle, and they were supposed to bounce out and then toward the other side of the field after they'd been scored on your side of the field. So most robots, they collected the ball. The really good ones like kind of pinched it, and then they like either they could drive all the way up to the goal and just sort of like let go of it or kick it in a little, but you could score from anywhere. So really good things that we saw this year was you could initially, what everybody looked at was putting a hook on top of this horizontal bar and then winching themselves up. This is how a lot of previous games had you doing the end game. But the rule was you just had to be suspended by this whole structure. So a lot of really good teams just had just reactive, either they drove up that with 2 wheels on either side and just the cantilever of their robot did that, or they latched onto it and just winched their robot up rotationally to get it up there. That way you didn't have to have too tall a thing to deal with, and it was because you could drive through these tunnels in between the bumps rather than going over the bumps. So being able to do both of those was advantageous. So yeah, 217 and 148 made the same robot that year, and they were one of the first ones to reveal a very good like pinch gripper thing, and that kind of swept through. And there was big questions about legality, but it worked out that just a lot of people had better collectors after they kind of adopted that. But the big one was, the rule was you couldn't control a soccer ball with your robot, with anything that was above your bumper line. Now, control was the problem. So 469 had just a ball redirector, and all of the rules in the entire manual were written so that you couldn't do this. The thing that saved 469 was at no point while a soccer ball was in their mechanism did they change which side it would come out of. And that was the way that it wasn't deemed to be control. They lost to Einstein. But this was such a low-scoring game. It was like soccer. You're scoring a soccer ball at a time. There were 12 balls on the field, but teams were not good. What happened in 2010 that really hurt this game actually was weather. There was a huge series of snowstorms on the East Coast from like the mid-Atlantic, from like Washington, D.C. area up. Every Tuesday there was a snowstorm. The teams in what would eventually become the Mid-Atlantic District, like Eastern Pennsylvania and Delaware, lots of schools lost 3 weeks to snow days just during build season. So this was the first year that there was a withholding allowance, because you used to have to put your robot in the crate at the end of build season and it would get shipped off to the regional that you were going to. And in between regionals, you could do a certain amount of work and bring in like a very small amount of either direct spares or like a very low weight allowance for upgrades to your robot. This year, there was something called the withholding allowance. You could bring like 40 pounds of stuff you could work on after the build season to bring to competitions, just because so many teams were behind. But even with that, not a lot of teams were very good at holding onto the soccer ball, because it was the specific soccer ball brand that they had this year. And soccer balls apparently have very different like coatings on them. So teams would be practicing with like a soccer ball that they got at the mall like sporting goods store. Yeah, their collector wouldn't work on the ones on the field because the coating was so different that the balls would just act completely differently. 2010 was just not a lot of scoring going on. There were quarterfinals rounds that went to like 5 matches, because you just have a 1-1 tie, then 1-2 somebody be up, then like a 3-3 tie. It took a long time to get through those matches. 2011, you were again similar sort of game pieces to 2007, inflated toroids, except a third of them were real, like, round toroids, and a third of them were kind of like squares, and a third of them were kind of like triangles. So it was the first logo. And your aim was, on the racks that were in front of your driver's station, you tried to put a triangle, a circle, and a square, a triangle, a circle, and a square. And you would get bonus points for making a logo, Logomotion. And the other part of the game was, at the end, you could have your mini-bot, which was a little robot made out of entirely FTC legal parts. You could have that drive up a pole and hit a pressure pad thing at the top, and that was worth points. Now, fixed number of places to score, and there were only 2 mini-bot poles per alliance. And the way that mini-bot scoring worked was the team that triggered it first got points, team that triggered it second got less points, team that triggered it third got even fewer, and the team that triggered it last got even fewer. But if your alliance got first and fourth, that was 40 points. So, and second and third together, 35 points. So if you got first and any other mini-bot and any other place in the mini-bot race with your alliance, your opponents couldn't outscore you on mini-bots. And the way that scoring worked with the Logomotion was the low rack, there were 3 levels that you could score on. And the bottom one, each tube was worth 1 point. So you couldn't overcome the delta of the mini-bot scores by scoring on the bottom row. So you pretty much just stayed even at high levels of play. You stayed even on the number of game pieces scored. And then whoever won the mini-bot race won. It's very anticlimactic, Einstein, because there was an alliance that just had way better mini-bots, and they would basically keep pace with tubes. So your human players were on the other sides of the field. You were scoring toward yourself. So as you scored, especially if you scored in the middle row, those are in front of where you can't see anymore. There's a thing in the way. And these are 38 by 28 robots, and your scoring area is limited because the loading zones for your opponents are on the sides of it. So 3 robots jockeying for space in there when you can't see anything. There were some alliance miscommunications that happened. So you'd look at this, and your loading zone's on the opposite end of the field from where you're scoring. So you're driving back and forth. No, you could throw the tubes. The human players could just chuck the tubes across the field. So the human players chuck the tubes across the field. Teams would turn in place, pick it up off the ground, turn in place. It's a little too easy in what actually worked out. So, like, best robots this year, it was entirely divided. You could be the best tube scorer and just have nothing for a mini-bot, and vice versa. There were, like, the best mini-bot robots in the world were 973 and 118 probably by the end. They were probably the fastest little thing that went up a little ramp onto the middle pole. It was all magnets and little terrible Tetrix motors. It was fine, but it was this race. It was a race in the micro sense, like in each match, a race to get up to the top. And in the macro sense, you had to make an ever faster mini-bot because you were fighting against the entire field of teams that were playing. Yours just has to be the fastest. So hundreds and hundreds of iterations of these little things. But in terms of tube scores, we see an excellent example here of Pink Arm able to pick up on one side and deliver on the other. And similar to a lot of games, you could start the match with one game. You could only ever hold one game piece. In the start of the match, you could have a game piece that was touching your robot. So there were a lot of 2 tube autos from a team that was very good at scoring, and you could just have your partner sit there and you could grab the tube. Pink team did have a 3 tube auto. It wasn't super consistent. They didn't really run with it at championships. But what we saw a lot of in terms of robot architecture was an elevator with a little elbow thing and a roller claw. This was almost all roller claws. There were enough motors at this point. So 177, there's an elbow on an elevator. 254, there's an elbow on an elevator. You didn't need any sort of reach because on the field, the dotted line at the ends, that your opponents couldn't go in there and touch your robot. So you had a protected scoring zone. You also had a protected loading zone, so huge protected areas of this field, big penalties, because Like if you touched your opponents while they were trying to score the mini-bot thing, like yellow card and whatever else. It was just like huge penalties with loading zones and protected zones for scoring right next to each other. Lots of very high leverage moments. Robots pushing their opponents into their own scoring zone, and then the huge question of, are you forcing your opponents into a penalty and because it's a red card for doing that? And so that decided some things. But scoring things one by one, and all three game pieces, you acted exactly the same. Yeah, they were different shapes. You pinched them, roller claw. 2012. The center of the field had a barrier between red side and blue side. It was 4 inches tall and 4 inches wide. It was just a rectangle. It was a little piece of stamped steel. Very hard to get over. So to help you get over it, and also to do other stuff, there were big teeter-totter bridges. But there weren't ramps down from the ends of those bridges. They were just flat planes that could tip and then balance in the middle. And what you also had was protected scoring zones. The key, so not that entire area, but just the place that has the red and blue plastic. If your robot was touching that, your opponents couldn't touch you while you were trying to score. And your aim was to shoot, you could hold 3 at a time, basketball poof balls into baskets. And the top one's worth 3, and the middle ones are worth 2, and the bottom one is worth 1. So you also had, at the end of the match, you could double balance on the bridge with your partners for 20 points. Until playoffs, when you could triple balance for up to 40 points. But in qualification matches, you couldn't get any extra points for triple balancing. Instead, there was that middle bridge on the field, the cooperation bridge. And this was sort of the nascent concept of ranking points. You would get direct ranking points from balancing with your opponents on the cooperation bridge during qualification matches. So that was worth basically the same as winning. So it was very high leverage play, these bridge balancers. The balls were worth 6 in the top in auto or 3 in teleop, and then half that. Or no, 6 and 3, 4 criminally. 3, 2, and 1 in teleop, and then double that for auto. So it wasn't a flat auto bonus, it was just doubled. And you could start with 2 in auto, and you could hold 3 during the match. So you had robots that passed balls to each other during autonomous for the teams that shot better. So you could shoot from these keys, you could shoot from anywhere into the goals. But a poof ball, as soon as it leaves your shooter, becomes like a foam brick. It's very hard to shoot them long distances. These are even worse than the dodgeball style rhino skin ones. The air gets into them way more. There's huge amounts of air resistance. So you mostly drove all the way up to the fender, like right next to the thing, and shot from there, where you weren't protected from your opponents, but it's hard to push you. You're up against the thing. Or you drove to your key and you vision targeted your way and shot from there. Now, the best robot this year was probably 1717. This is a robot with 4 independently steered swerve modules and a killer turret on top of it. Great autonomous modes and everything else. Way ahead of their time. They look like a modern robot, and this is 2012. But another extremely strange robot, no turret, no swerve, was 67, and they had this gorilla arm thing. So they would pick up the balls and they would dump them into the top of their shooter hopper. And it was, why do you want to have this like disconnected sort of ball transferal thing? It was for the other thing that the gorilla arms got them. So they could push down on the barrier with that and lift their wheels so that they could traverse that like really easily. They could lift the drive base wheels. And then at the end of the match, they could continue to drive this thing down and use it as a pogo stick, a stinger. Lots of teams called them stingers that year, to help triple balance the bridge. And this gorilla arm, you will see versions of that basically forever. In terms of like what other teams were able to do with with an extension to go out and collect balls, this multi-use extension was the model for just a whole bunch of other things later in FRC. Another really good robot this year was 341. No turret, but a high shooter, and just a good version of an outboard collector, a collector that folds out. This 1717 was one of the few really good teams that didn't have something that went outside of their robot to collect balls. Most of the really best collecting teams did this. Your human players could either feed your robot directly if you drove all the way over to them, or they could whip the ball at the bottom of the opening through which they could throw the balls, and it would bounce all the way across the field. So it obviated like a big part of how the game was supposed to be balanced. You're supposed to have to like drive across the field somehow to get balls, but human players just solved that problem. So then, even though there were a lot of teams that really got good value out of being able to cross the barrier, across the bridges really well, it wasn't as big a detriment to like your scoring cycle as it seemed when you first looked at the game. It wasn't as divided as it looked. But 341 had an excellent auto where you would start with balls, and there would also be balls on the bridges, and they would drive away from their scoring area, tip the bridge down, collect those extra balls, and then drive and score. And just an extremely simple robot just turned its drive base to do all the vision tracking. So because of the rules around bags or crates or whatever, build season was kind of after the 6.5 weeks, you wouldn't really have full access to your robot. So it was difficult to make major iterative changes. So most of what you conceived of at the beginning of the year and then executed, that's what you had when you went to competitions. And we didn't see like good S-curves or path planning or motion magic or anything like that. Teams were just getting into the habit of really actually using internal and external sensors to actually make interesting autonomous modes. These mostly, when you look at the game and you look at the values and the places where you had extra game pieces, you would drive in a straight line to go get them, and you drive in a straight line to get back. 2013, the game piece was fantastic. It was a frisbee. It was a Whammo frisbee. And unlike all the other things that we had shot up to this point, when it left the robot and it was spinning, it would generate lift. So you could shoot these things full field with a little bit of practice or like a system that actually worked, and it would just consistently go where you wanted it to go. So you could hold up to 4 frisbees at a time, and there were huge vector pyramids on the field. At the end of the match, if you were hanging on the first rung, you have 10 points. If you were hanging on the second rung, 20 points. And if you were hanging on the third rung, 30 points. But each frisbee in auto was worth 6 points. And you would start with 3, and there were 4 more under and ahead of your pyramid to pick up, and 2 more in the center line. So really good teams had a 7-disc auto, and each frisbee's 6 points. So 42 points in auto just from one robot. When like the best thing you can do climbing is 30 points, and then you could also there was a little platform at the top, and you could deliver 4 colored frisbees into there, and each of those was worth 5. So if your robot was just centered on doing the climbing and the dumping, you could get 50 points. And 50 points sounds like a lot until you can score 42 points by scoring the game pieces through like the regular places that you score in auto. So the balance, it really wasn't worth it to go up to the top, because you would get 10 points. You could get 10 out of those 50 just by having something that could passively hang on the bottom rung of this pyramid. So they were big red herrings. But you had the corners of the field, opposite corners for red and blue. That was a protected zone. And then on the other side of the player station, it was an unprotected zone to load frisbees with human players. And if you were touching your pyramid, your opponents couldn't hit you without penalty. So 2012 was also the first year that penalties became fouls, and they became you gave your opponents points for them. Before that, you just deducted from your own score, which doesn't really work, and this is a much better system. But lots of robots this year really kind of got it down. So a very good example of the 7-disc auto is what Code Orange put out. So you'd start in like the middle of your pyramid, and to collect frisbees, lots of teams collected them just under their bumpers, because they were under like the bumper zone that you could have. That was probably the best way to do it. So they had holes in the center of their robot chassis for frisbees to pass through. And 469 had a similar thing. So not only could they load from the top and just slide down this ramp into their top swinging structure thing that shot frisbees, but they could also, these polycords in the back, there's a collector in the middle bottom there, and they could drive over frisbees and just pick them up. 469's robot that year could shoot full field. They're probably the best full field shooter. They could shoot from the back of the pyramid, the side of the pyramid, the front of the pyramid. I saw them do all of this in one match. They were absolutely fantastic. And we saw other teams pick up some other things. So like another kind of full field shooter would be what 1519 put together. They couldn't go under the pyramid, so they had less maneuverability, but they would drive over to where the human player could load. And they would just sit there and shoot from high and shoot into the high goal. And then it was hard to block them. Where you could have your blocker was very complicated, because if you were close enough, then they could just drive forward and earn a penalty from you because you were in your loading zone. All of these things. 987, that thing is on a turret. Their frisbee shooter thing could go like this, and they shot super, super well. But the pyramids were this whole thing about climbing, and did you need to have both of these things? And it really came down to very fast cycles of shooting 4 frisbees into the high goal super, super well. A great game piece. 2014. The same game piece as... in 2013, it was the first year that they shrank the robots down. So then it was the equivalent of 85% of your perimeter. So robots were way smaller, so much more room on the field, way easier to like put a game together and have robots driving faster. All these robots are driving at like max 14, 16 feet per second, and those are like the robots that are going super, super fast. Everybody's going 11 and 12 feet per second at this point. So aerial assist, they take the same game piece as 2008, they make it slightly smaller. And the game design committee, they're trying to fix Overdrive, because they thought that the cool thing would be you'd pass the ball to each other, and that would make the laps shorter. So in 2014, they made it so you had to pass to each other to get more points. So you could your cycle could be up to 50 points if all 3 of your robots controlled the ball in each of the zones, divided by these white and blue tape lines and red tape lines, and 10 points for throwing it over the center truss, and 10 points for catching it, and 10 points for in the high goal. Catching was like it had to touch your robot and get into your robot without touching the carpet or anything else. That was really hard to actually get working in cycles. So these boxes on the side of the field are where your human players were. If the ball went outside the field, your human player would get the ball and they could throw it back into your robot. And that's how teams made really, really, really efficient cycles. Was one robot would get it in the beginning, they would hold it in one zone, they'd pass it off to another robot who would get into the white zone, chuck it over the truss to a human player, or just onto the field. But a lot of teams use the human player. And then that human player would throw it directly into the third scoring robot, and they would drive over and shoot in the high goal. So your alliance only had one ball at a time. You wouldn't have access to get another ball onto the field until you scored the one that you had. Except for auto, you could have 3 balls. And again, each robot started with 1. But what if you were the best robot at scoring balls? So what if you had a collector on the front and the back of your robot, and you just drove with all 3 of them over next to the goal and shot them all in? So 254, this was really ahead of the field. They had a 3-ball auto, very consistent. There were also hot and cold goals. In auto, you could get up to 5 more bonus points if you shot in either the left or the right of the upper goal. Again, you couldn't extend above a certain height in this game. The left or the right, depending on what the field told you was the hot goal. So they would drive over to where the hot goal was going to be in the last 5 seconds of autonomous, because it was 10 seconds of autonomous instead of 15 that sometimes you get. And then they'd shoot all 3 in within 5 seconds. But there were a lot of very good robots this year. So since it was similar to Overdrive, there were a lot of teams that iterated on the 1114 robot from that year. So 971 has a big puncher. So they just winch that thing. They rotate up with the ball, and then they fire it, and that thing came out like a cannonball. They shot that thing so far, it was ridiculous. And 368 was one of the teams that had a very good independent swerve system that year. So you see that teams would make these catchers. Their robot could expand out to the side to try to catch the ball. But it was just very difficult to coordinate that. So the big thing about 2014, you have one ball and 3 robots, and you're passing it off to each other. But when you don't have the ball, you can't do anything else to score for your alliance. So 2/3 of the time that you were out on the field, you were playing defense. Every single robot on every single alliance. It was a lot of bumper to bumper, like driving into each other, trying to redirect them slightly so that they couldn't get the trust shot or the transfer to their second robot or the shot into high goal to work. You could also shoot it. You could also deliver it into the low goals and the corners. That was worth 1 point instead of 10 points, but it would reset your assist cycle. That was the passing of the ball from robot to robot. So the meta was if you missed a high goal shot, it would go out the field somewhere. It would bounce off the field in some way. And your human player would get it, and you'd throw it back into the robot. And very often, if you were the team that shot that again to the high goal, everybody's mad at you. Because if you miss again, the other 2 robots on your alliance still aren't getting the next ball. They still aren't starting the next cycle. So the best thing to do if you miss the high goal the first time is just dump it in the low goal. You take that 9-point penalty so you can start the next cycle. You'd have to get this going. So Einstein for 2014, very enjoyable to watch, very driver's game. Lots of, they're all driving against each other 100% of the time. 2015, the opposite game. The field was divided with a step that you could not cross. You could not go to your opponent's side of the field. The only interaction available in the game was during autonomous and then something else during qualification matches with a cooperation tote stack. So the game was, there were a bunch of the totes on the field, and you had to stack the totes, and you could stack them up to 6 high. And you would put a recycling bin on top of the totes, and that would be a points multiplier. And you could put litter, which was a pool noodle, inside of the recycling can on top. So there were 10 total cans. Your alliance started with 3 on your side, and there were 4 on the step. So at the start of autonomous, you could try to get them off the step. This is, again, a race. You're racing directly against opponents in front of you. And teams had these fishing pole whips or whatever to try to get something into the can and drag it toward themselves. The other big point value scoring that you could get is during auto, you could move the totes, the yellow totes, you could put them in a stack and put them in this area between the 2 scoring platforms. And that was worth 20 points. And you could put the 3 cans, or if you could get 3 cans into that same area, that was also worth 8 points. But most teams that stacked in autonomous, they just kicked those cans out of the way for later. They would just stack the 3 totes, put them in the zone, and that was it. While their 2 partners were fighting over the cans that were on the step. And then you just had to make as many stacks as you could. So most very good robots. So there were 2 parts of the field that you could get totes from. Your human players back here, and you could slide one at a time the totes through a chute. Or you could get them from the landfill, which is this area next to the step. They called it the landfill. And you just picked up totes from the floor. So your robots could be any size during the match, as long as they were on your side of the field. You just had to be able to get them on and off the field in a transport configuration that made any sort of sense. You could have them folded up in all sorts of funktastic ways, and then you put it out on the field, and then you take lots of teams figured out how to make the human player loading even better. They put a ramp next to the human player thing, and they just attached that ramp to their robot with a really long tether of just something that dragged on the ground. So their robot was 15 feet long technically, but it's just a ramp that sits over there, and the robot's driving around. There were teams that made 2 robots. They were just tethered together, just 2 entire robots. And mostly the best way to stack the totes was somehow get them into the middle of your robot base. So you need a big opening, and then pick up from the sides, lift it up one tote height. and then you could bring that elevator back down and lift it up again, and you would do that 6 times. And something else would be dealing with the can on top, different ways of doing it. So 11-14, again this year, up until championships, they were so much faster at just stacking the totes. Their thing moved the tote up in the stack faster, that they were like a standard deviation ahead of everybody else in terms of scoring. They also had a good thing that got the cans off the steps, so they just had more stacks that they could make. But the team that had like a really, really, really cool thing, 28-26, they made a garbage truck, because garbage trucks like pick up recycling cans, so they just put that on their robot 3 times. So when they did the autonomous stack with the autonomous totes, they would just drive forward, pick up one of the cans, and keep it on their robot. They'd move it off to the side, pick up the tote, and then do that 3 times. And so then when they went in after auto, they got 28 points instead of just the 20 for the stack. Did the camera stop? Or did it just make noises? Okay.
It just went to sleep.
So they had higher potential there, because controlling both of those things was very complicated. It's just easier to move those cans out of the way and deal with them later. But these were just huge structures that you had to deal with. These stacked totes were just light plastic stacked on top of each other. They could topple over pretty easily. And you were trying to fit them all onto these scoring platforms, which once you get 3 or 4 things next to each other on there, it's really precarious. You have to really coordinate with your partners to make sure that you're not knocking over your stacks with like your tether that you're just dragging around the entire field. So what really came out of this was how to pick up an object that doesn't roll away from you in FRC. It's boxes. And it's the sideways rollers, and it's some sort of compliance in there. So 118 had a very good version of that. 11-14 had an excellent version of that. Just a couple of spinning wheels that really just shot the tote into their robot, and then they could manipulate it from there. 28-26, they just got it from the human player. But very valuable. Overall, with 10 recycling cans on the field, you only had access to up to 7 if you somehow won all 4 of them off the step. So you only had to make so many stacks, because each tote by itself was worth 4 points or 2 points, and a full stack with a can with a noodle on top, it was worth 42 points. So it was really about who could get to those on the step first. So those can races were terrifying, because teams they wound up a whole bunch of surgical tubing in a winch, and then they would just fire it at the beginning of the match. A whole bunch of stored energy just flying at each other at the beginning of the match. But because the field was divided, your ranking was not based on how many matches you won. It was based entirely on your match score. You were not playing against the teams on the opposite side of the field from you in qualifications, nor were you in playoffs. Instead of quarters and semifinals, they had an almost round robin. You would play 2 matches against 2 different alliances, and your alliance's average score, the top 4 of those would move into semifinals, and then the top 2 of those would move into finals, and then it was a direct head-to-head, best 2 out of 3. But you kind of cared what your opponents were doing, but not really. So this allowed for a lot of really fragile designs. You could make a robot that was held together with hopes and dreams and like baling wire and spit and stuff. But if it stacked the totes, who cares? Nobody's going to run into you unless your alliance really screws up. Nobody is trying to stop you from doing it. Lots of really cool robots in 2015, but it wasn't a game. The only time that your strategy and your opponent's strategy mattered to each other was the first 0.15 seconds of the match as you're fighting over these cans in the middle. It was a very weird game. Not a lot applicable in terms of strategy from that. 2016, FRC got the Disney Imagineers to help them design this game, because they'd had a couple of sort of themed things, but nowhere near as strong as the themes in FLL games. 2016, it was, all right, the theme of this is you are storming your opponent's castle. And what really drove them was, no, every time you're trying to figure out what the rules are and what the objectives of this game are, you go back to that central question. What are you doing to storm your opponent's castle? So there were there were these big defense row things, and you had to break down your opponent's defenses, and then you had to knock down their tower, and then at the end of the match you could climb what remained of their tower. And so this sort of clarity of vision thing really worked out for them. It was a very evocative game. But what was actually on the field, the scoring object was, they called them boulders. They were 10-inch dodgeballs, so the rhino skin things. You could hold one at a time, and it was worth 5 points to score in the high goal in teleop, but 10 in auto, so big thing there. This was the first year of ranking points. So you could also earn ranking points in addition to the win-loss tie for breaching 4 out of 5 of your opponent's defenses, or capturing the tower, which is scoring 10, or no, it was 8 game pieces in your opponent's tower, and then later 10 at championships. They just upped the number that you needed. And then in playoffs, those ranking points converted into flat point bonuses. So whatever you were doing for ranking points actually directly translated to your strategy for playoffs that year. And you could also, so part of capturing it was not only getting 8 game pieces in, but you also had to have a certain number of points or robots on their tower at the end of the match. And you could climb on these little tiny horizontal bars up here, and you had to get your bumpers above an invisible line. Now the defenses. So on the left side of the defenses that you were going up against, there was always the low bar. This was a bar that was 16 inches off the top of this platform. Your robot had to be short. 16 inches with, so you had a little entry ramp into each of these, and then you had to get through this low bar. That meant that to actually get through it as your robot was coming up, your robot had to be about 14 inches tall or less to get under the low bar. And then you had to have a whole bunch of mechanisms on it to actually do stuff. Collect balls, score balls, climb. Phantom couldn't go under the low bar. Not even close. Like several inches too tall. So that's how short these robots had to be. So the other defenses, the low bar was always there, but the other defenses were chosen by your opponents. Each set of defenses, they could pick from one in the different bays, and they were paired up. So you could have the rock wall or the rough terrain. And the rock wall was like the barrier in 2012. It was just a tall rectangle. The rough terrain was a bunch of small, irregular rectangles, just welded steel on these things that they would put on and take off the field. They like slotted into things on these defense rows. And so the field took a beating this year. You had to go over these like individual teeter-totter things called the cheval de frise. You had to go over these fixed things, these moats and whatever. And there were also the sally port and the drawbridge. And those, you took down your opponent's defenses by going from the center to your opponent's courtyard twice. You had to go all the way over it in that direction twice. But the sally port and drawbridge, you had to pull something toward you to open up the opening. So those were not the most defeated defenses. If you were getting 4 out of 5, that's the 5th. You had a team that could go under the low bar. You had a team that could go over these weird, like, 2 opposite ramps things. Most of the teams that were successful this year defeated all these defenses by just having a bunch of pneumatic tires in a tank drive. Like 8, 10 pneumatic tires just all next to each other. They just bounced over these things with abandon. But just horrifying amounts of abuse to this field. The defenses, like, they locked in pretty much, but sometimes they'd come out and you just had a field fault. Like, it would just come out and they were on casters and they just roll away. You had to go, well, you broke the field. Whoops. So you had your loading zones. So red was scoring this way. They were scoring into their opponent's tower. So this area, which was defined by the berms, which are the short rectangles that they used to corral balls in 2019, and then all of the rendezvous point in 2020. It's the little short, like, steel tubes that just destroy your wheels, but pneumatic tires, everybody was fine. A lot of teams did tank treads, and this was one of the things about having an FRC team for a long time, especially in past years' games, if you've been around for long enough, your team's tried tank treads once. And almost every team once. You don't go back to that well. 11-14 had tank treads in 2006, and immediately it said never again. Just when any sideways force is applied to your robot, then your robot can't drive anymore because the tank treads fall off of the wheels that drive them, and then you're done. It's so many more shafts and things that you have to make. They're awful, and a lot of teams found that out firsthand this year, and they watched these teams just driving over it with just a regular drivetrain with some bouncy wheels, and went, "Why did we think that tanks were the answer to this?" 190 did that. We did tank treads. So you would roll these boulders, one at a time, and a lot of the best robots went onto the low bar, so they were really short ball launchers. So there were a bunch of different ways to make it so that you could shoot well while you were in your defenses. So if you hadn't crossed all the way over into your opponent's courtyard, they couldn't touch you while you were going through the defenses. This was to prevent defending going through these defenses with all the weird stuff in the way. They didn't want the field breaking. They didn't want you breaking your robots doing that. But that also meant that while you were going over, just before you got all the way, you could shoot your ball. You could shoot from pretty far away, and you would be protected. And then you just had to... The rule was you could only launch a boulder... Okay. Each time you went over the defenses, and you actually crossed into your opponent's courtyard, went over the defense, but not all the way, and didn't actually clear it, shot the boulder, and then went back for another one, that was a penalty. You had to get into your opponent's courtyard fully for each time that you scored a boulder. This was to prevent some sort of weird gaming of basically the economy of the boulders that existed on the field. So 2-ball autos, very, 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 very hard. You started with one, and you lined up in front of your opponent's defenses, and then there were ones that started in the center line, and you couldn't cross the center line, but you could grab that boulder with just like the leading edge of your robot, but you can only hold one in all of these things. So there were, by my count, 5 robots that could do a 2-ball auto: 195, 254, 971, 987, and 1678. And I used to think that there were 6, but I can't remember the 6, so I'm saying there are 5. But there were other robots. There were other really successful robots. 2 examples of which: 1241 Theory 6 and 2481, the Roboteers, who said, "Yeah, the low bar, that really curtails what we're able to make this robot. So somebody else is going to deal with that. We're just going to make a tall robot and just not go under the low bar. And then it's like really easy to have one 10-inch ball go all the way through our robot to have like a super good shooter." But all of these teams had to go under the low bar because that was the only defense that stayed the same. So your autonomous was drive under the low bar, shoot your first ball, come back under the low bar, grab the second ball, go through the low bar again, shoot it. So to get this to happen, some of the teams went to the extreme. So 971's robot, they're in the back here. They drive over this defense, it's all pneumatic tires. And then they get ready to shoot. Everybody looked at this and said, "What? How?" 971's controls were very far ahead of everybody else. That kind of looks like a modern robot, right? Like motion magic. There was no motion magic. There were no brushless motors. 971 was one of the teams that developed something like motion magic before it existed as like a library or like a resource that a bunch of teams could use. Very complicated logic to get everything to work in coordination, because this thing has to fold out in such a weird way to work, because the ball comes into their robot, into their shooter holder thing, and then they want that shooter holder high so they have a good view of it and they can shoot from closer to the goal. So that thing goes like this and is also on top of an arm, and none of it's mechanically linked. It's all like different motor drives. It's very complicated. Other teams this year that were very good: 1241 again, like a turreted shooter on top of pneumatic wheels. Like they were just super good at shooting boulders one at a time. 987 went under the low bar. This whole structure folds down. So they collect with this outboard collector that pulls it into they love sideways shooter wheels. They pulls it into their sideways shooter wheels. and then that thing comes up to shoot. That thing is on a turret. This weird little arm also is on a turret. They love turrets. But really interesting to see a lot of robots try to package like a full... So more districts are popping up by this point, by the 2016 era, but there were still teams around here that would go to championship as a serious championship contender and had been to one regional. So they'd done 15 matches, 9 qualification matches. Maybe they get 6 or so elimination playoff matches, and they go to championship, but they're super good. This is kind of the end of that. Now everybody plays. Now everybody has to run their robot a lot more. There have been individual teams have made practice robots since before 2005. There have been teams that have had this extra robot time, but the first iteration before, with the C-Rio, the different electronics components that went on your robot, they were all from different vendors. They were kind of pushed together and tested enough to mostly work, but there were a lot of points of failure just from things that had never talked to each other before they were put on an FRC robot. So lots and lots and lots of controls issues. Because we were still in the 2016, or 2014 was the first year that you could use more than 4 sims on your robot, more than 4 of the big heavy brushed motors, high torque, high power motors. So lots of different gearings on your drivetrain. You would have something that moved it from going 8 feet per second to 16 feet per second. So manufacturing capabilities still come into a lot of things. And vision targeting, you certainly saw it. A lot of teams used it pretty effectively, but more effective in a lot of these games was you would drive over to something and push your robot against it, and then that's where we fire from. And as long as you go back to the same point every time, it's going to come out of the robot the same. So lots of indexing. This was also, around this era is where there was a whole blow up of, well, what if we had a really good version of this small mechanism that could go on a lot of robots? We just bring it to competitions. And when we pick these teams, we help them install it. So then we all have this really good version of something. It's called cheesecaking. I don't know why it was called cheesecaking, but it was this very weird power dynamic imbalance thing, and it was eventually made illegal.
125 named it. Brando named it.
Yeah, 125, the Neutrons named it cheesecake, and it was such a weird thing, and it affected in quasi-positive ways. It's not a simple thing, this how much is helping teams reach their potential thing versus parts that they didn't make, that they didn't design, whatever. So 2017 Steamworks, they're riding the high of a very, very, very themed game. So from medieval sort of European castle theme to steampunk is the 2017 game. So this was a cycling game. You drove over to your human player who would deliver you a gear. It was a big plastic gear facsimile thing. And you'd drive it back and you'd give it to... This year, your human players were on the field. They stood on these platforms on the field. A whole bunch of liability things they had to make sure. You could get a yellow card very easily for reaching out of the airship. That's what they were called, the airships. So you would drive your gears over to these human players, and there was a peg on a slot, and you would deliver the gear to the peg, and the kid would bring it up, the student would bring it up, and then put it onto different structures on this airship. And after a certain number of gears, you would be able to turn a rotor, and those were the little propellers on the side and the middle one. And that denoted that you had enough gears to earn the next. So these were big gradients of scores. It took 1 gear to get the first rotor, 2 more to get the second, then 4 more to get the third, and 8 more to get... So there were huge score jumps because each rotor was 40 points. So 1 gear is worth 40 points. 3 gears is worth 80 points. 12, these big jumps, each in discrete scoring action. Each discrete robot action is not necessarily a discrete scoring action. And the 2 other things on the field were, at the end of the match, you could climb a rope that dropped from your airship, and your robot would push a pressure pad. And the rope, you could use the field rope, which was a 1-inch thick braided nylon rope thing, or you could use what could be referred to as a rope, which is a strip of Velcro, because you can just put Velcro on a drum and spin it, and you can definitely climb with that. That's what everybody did. And the third aspect to this game was the fuel. And there were 500 fuel balls on the field, well, outside the field. You could start with 10 or whatever, but each of these held 40 or 50 or something. Each half of these hoppers had 50 things. And on one side, a mirrored field, on the audience side of the field was one boiler for each alliance. And there was a low goal, which was hilarious. There was a high goal. And in the high goal, during autonomous, so it was, you weren't shooting at a horizontal goal. So you weren't trying to have like a flat trajectory. You were trying to get a big arc. It was worth 1 point and also 1 kilopascal of pressure, which was the thing that was the invented thing to get you toward the ranking point. If you got 40 kilopascals of pressure, then you also got that ranking point for the fuel aspect of it. And then in playoffs, you would get a bonus of 20 points or something. And the rotors, if you got 4 rotors, that was worth, if your alliance got 4 rotors, so like all the gears, you got a ranking point for that, or 100 points in playoffs. And the other thing about the fuel is during teleop, each fuel ball in the high boiler was worth 1/3 of a point, 1/3 of a kilopascal. So either you got a bunch in auto, or you were shooting the whole match just to try to get up to that 40 kPa. So really imbalanced score values there. There were a lot of things that pushed teams away from a lot of teams developing a good fuel scoring system. One is you needed to have a pretty big portion of the field to get this autonomous to work. You had to drive from in front of your alliance station wall over to one of these hoppers. It had to be high fidelity enough hopper that you could actually push it and tell when it thing. And then all the balls would have to roll into your robot, and you'd have to have an entire boiler, which had a vision target, but everybody just indexed off the field for that. You had to get this whole system to fire a bunch of balls very quickly into the thing. And then, if you were super good at it, you had to do it again on the other side of the field, because your red autonomous is a mirror of your blue autonomous. And this plagued teams throughout. One of the Einstein alliances ran a different robot to the hopper to shoot into the boiler, depending on whether they were red or blue. Like the best teams in the world found this really difficult to do. And the other thing was 100 points in playoffs for getting 4 rotors. You got to get those gears. You really got to focus on getting those gears. When the gear mechanism, the thing that your robot had to have to get a gear, there were teams that picked them up from the floor, certainly. But since you could not throw a gear. The human player unable to actually get it very much closer to your airship, no matter what they did. So you could pick them up off the floor. Or you could drive over to the human player thing and have them drop it into a box, like a box. And then you drive over in the peg, you could just drive right onto the peg and you could lift it out of the box with your other human player. So a lot of teams spend a lot of resources to try to figure out how to do gears when what they needed was a drive base. So not a lot of resources overall in the FRC sphere went into dealing with fuel, because going between 3 and 4 rotors in playoffs was like, if your opponents were getting 3 and you could very occasionally get 4, you would win every single match that you got 4. There's just no way to make that up with fuel. So only at the tippity top levels was fuel a decider. But one of the ways that teams made a good fuel system robot was 2 streams of fuel coming out of the robot next to each other, rather than like a 1x1 shooter. It was just 973, for example, just had a big spindexer, weird like agitator hopper, and just polycord up to a double wide shooter, and they just shot a whole bunch of fuel at once and got pretty accurate. But if you have a high enough volume, you're going to get results from it. Other teams went 1x1. Titanium this year, 1986, they had a big weird agitator hopper thing, and then one at a time it came out of their big flywheel shooter, and they were super good. It was a little bit lower rate of speed, but very, very accurate. a couple of teams like 125 made a. They were inspired by the hopper for a paintball gun, which has like a scoop with rollers on the scoop that then feeds that into a central challenge. It's really cool. If you get a chance to look at it, if you have a hard plastic game object that you're shooting, it's a really, really cool way to do it because you can put a turret on top of that very easily where the other like big hopper into something. That wasn't a turret. And other teams, 5687, didn't do much with fuel. They had like an active gear drop-off mechanism, or there were teams that they could just getting your gear off the ground. It's a weird flat thing, but you just have rollers on top of like a little scoop and you roll it in and then you can rotate that up. Spinning rollers at stuff is how you pick up like every year. 2005, we are very, very, very far past the era of put a stick into the middle of the game piece one at a time. You spin rollers at it. 2017, very, 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 very close to being a really interesting game to watch. But the overemphasis in the point values for gears made that it was just a lot of cycling, just driving back and forth. But if you want to watch an amazing match, the last round robin match, this was the first year of 2 championships. The last round robin match at the St. Louis Championships, 254 misses the hopper that they go for in auto, so they've scored only like 10 KPA in autonomous when their opponents score a whole bunch. I think they get over 40. And then throughout that match, it's just back and forth and back and forth. They're trying to make the difference with these balls. Fantastic match to watch. And like the absolute pinnacle of that game, which most of the time, especially at most, I really think of games from the perspective of what does it look like at champs? What does it look like on Einstein in the final rounds? Like when the best are playing, how does this really play out? Because even as teams, all teams in FRC have gotten significantly better. The resources that are available for them to work with have improved dramatically. You can get a lot of good gearboxes from a lot of different vendors to be able to drive whatever. You have a lot more motors, just total number of motors available to you. The motors are better, all of this stuff. Resources in terms of team strategy and other things and sharing code between teams. Teams have gotten so much better, but still a lot of games at a lot of qualifying tournaments, you've only got a couple of teams that are really good at scoring. So sometimes it's really lopsided. But when you get up to the high pinnacles, that's what really differentiates games that I love, is what does it actually take to win when you're really playing against teams that are as good as you are? What's going to make the difference? Power Up. 2018, Power Up, my favorite FRC game. So good. One game object. It was an egg crate. They were called power cubes. It's not technically a cube. It's a rectangular prism that's slightly shorter in one dimension. But it was an egg crate covered with a nylon bright yellow cover. And that was the only thing you had. And there were 3 places to score. 4. No, sorry. There were 4 places to score. There was a big teeter-totter in the center, the scale, and there were 2 switches, which were smaller teeter-totters in little fenced-off areas. And then you could also push power cubes into your alliance station and put them into the thing back there where you could get power-ups. And if you put 3 cubes into those, then a power-up was available to you. So the way scoring worked was while one of the teeter-totters was tipped toward you, you scored 1 point per second. So you could have that with the scale in the middle and your own switch. So you could be scoring 2 points a second. If your opponent's switch was tipped toward your side, you weren't scoring points from it, but neither were they. So you could score up to 2 points a second via the teeter-totters. So both alliances could be scoring 1 point a second because the scale could be balanced. One could be scoring 2, one could be scoring 1. Power-ups were you could boost, which was however many points you're incrementing from the scale and the switch, they just double that for a short period of time. And you could also flip it, and you could just make it so that the scale and the switch were under your control. Just pretend that that's happening regardless of what's physically happening. That would be a power-up that could last for however it was, 10 seconds or 15 seconds. And the third one was completely orthogonal to that, because the other challenge in the game was climbing this tiny bar, this very small bar in front of the home platform thing. If you got your bumpers up above a line, you got points. And the third power-up, Levitate, meant that you got 1 robot's worth of climbed robot. So then you only needed to get 2 to get the maximum climb score. So this led to a lot of teams that were able to say, well, I can lift my robot really well, and I can lift your robot really well. I can't lift 2 robots really well, but I can lift 1 robot really well. And so a lot of power concentrated in terms of what you were able to do with like the best possible robots. But your 3 robots, as you were scoring, your opponent, so these platforms on the scale and the switch, each, the surface of it could handle 6-ish cubes, like a 2x3 grid. So then you had to stack on top of those. And if your grid was perfect, you could make like a very nice, stable structure. This was very, 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 very hard to do. Again, like 2005, the height of this is an unknown. You know how tall the structure is, but once you start putting more and more power cubes on it, you don't know how tall you have to get. So controlling game pieces from really high up above your base and placing them gently, that separated some of the top alliances, because you're putting 14, 16 cubes on here, and if your stack is really unstable, as anything moves or as you try to put another one on, you're dropping stuff off, the whole thing's tilting the other way, and chaos reigns. So in Autonomous, again, you could hold 1 game piece in your robot, and you couldn't cross the center line, but you could get to the center line, and you could score on your scale. So it was pretty clear from kickoff that if you could put a whole bunch of stuff in the scale, a whole bunch of power cubes in the scale as early as you could in auto, it would be really hard for your opponents to take it back. You're just ahead. So the best robot, 254, consistently was able to put 4 cubes on the scale on their, it was randomized which side of the scale was yours every match. You would either have all 3 on the right or all 3 on the left, or left, right, left, and vice versa. So you didn't know when you put your robot out onto the field which side you were going to be scoring on. So on their side of the field, they were able to consistently do 4, and if it was on the opposite side of the field, they could do 3. And this was difficult for other alliances, for other teams to do. So a race to the middle, but you're not driving up against each other. You're just trying to get stuff on the scale. So there were extra pieces all over the field. This was a protected area. Your opponents couldn't get them from this side of your switch fence, but the ones in the center were fair game. So that's where you fought over them, and your human players in the corners could also deliver them to you. And the thing that I love about this game is where you score affects where your opponents are going to try to score next. There were a lot of alliances that made great use of, I'm going to score in my opponent's switch, so that they have to spend time defending their own switch to get the points from that. Other matches, it was just pure scale battle. If we can keep this even or balanced toward our side, that's the only thing that's going to make a difference in this match. Very, very cool. 195 had a really, really, really thin elevator, because the whole thing was supposed to be on a turret, but it could go super high. 195 was one of the teams that was the absolute pinnacle of placing cubes in a controlled manner on a very, very, very tall stack. 148, this is, they did a whole bunch of round tube stacked next to each other elevator, because super thin wall round tube is how you get very, very light structure. Apparently it was like a pain to put together, but they got it working, and this meant that they could fly around the field. Their elevator was super fast up, super, super light, and so they were able to spend a lot of time on the opponent's side of the field messing with their switch and just get right back to their scale and put one up very, very quickly. And each of these teams that I've highlighted, and 2910 also had a great year. But each of these teams also had the buddy climb. It got termed the buddy climb, and it's actually great, and we've forever used buddy climb since then. And it was just something else that on the robot either went under their partner or into their partner or around their partner, or their partner drove on top of it. And when the team with the buddy climb lifted themselves, they also could lift their partner. And so this way you didn't need to coordinate two robots trying to get on that very thin bar. Though some teams did do that pretty successfully. But a very well-balanced game. 2019, Destination Deep Space. There were two game pieces. One of them was a very flat toroid. It was a thin piece of polycarbonate. It was pretty big with a hole in the center and Velcro all around the outside. And the other game piece was a cargo. It was a kickball, like from gym class. It's a bright orange kickball. And at the end of the match, an interesting game challenge. Usually there was something for you to hold on to, like a bar or something for you to climb at the end of the match. This was get on top of a flat platform. And then instead of autonomous, there were these curtains so that you couldn't see the field, and you had to play in the sandstorm on the planet Primus. The themes thing kind of goes up and down. I mean, nothing's going to reach the pinnacle of 2016. You need a lot of focus to do that. 2018 was all video game themed. But 2019, there's a sandstorm on this planet, so you can't see, but you can just drive. It's not autonomous. It's sandstorm mode. So if you had cameras on your robot, like driver POV cameras, you could just drive. But autonomous was slightly better for a lot of teams, whatever. In terms of points, on the central and outside structures on this field, the cargo ship and the rocket ships, you would put a hatch panel on, and then that bay could accept a cargo, and the cargo wouldn't roll out. So it was a two-piece scoring action to get like all of this. And there were 36-ish places to score. So you could start in autonomous with extra hatch panels on the sides of the cargo ship that wouldn't be worth points, but then you could just put a cargo in and that would get you the 3 points for the cargo. Or you could start the match without those and you would have to do both parts of it, but that's more stuff. So the ranking points, and the ranking points were really difficult. So after 2017, ranking points no longer gave you match points in playoffs. You just do them for qualifications, and then thereafter, those direct actions that you take won't have any commensurate reward. This is, 2017, they were so different and varied, the 20 points versus the 100 points. I think a little bit of gun shy there in terms of we don't want this to fatally overbalance one ranking point in the game. But it means that you're doing this stuff for qualifications, and then the playoffs are just a different game. In 2019, one of the ranking points was the rocket ranking point. So if you scored 6 hatch panels and 6 cargo, on one rocket, it was a ranking point. And you had to do all of this. But if you scored half of it on one rocket and half on the other, that wasn't worth the ranking point. The other ranking point was for a certain number of HAB points. That was the platform at the end of the field at the end of the match. And so that one you could not do it with only one robot's worth. It was like a lot of endgame ranking points where one team could get almost all the way there, and then somebody else had to do something pretty straightforward, and then you could get that ranking point. But the rocket ranking point was hard. Scoring 12 game pieces in a match is difficult. And then, because this big cargo ship's right in the middle, if your opponent has put 8 game pieces in the rocket, and you don't want them to get the ranking point, you can park in front of that rocket with your drive base. So it's very easy this year to defend a ranking point, which is something that really doesn't make sense. It means that you get very different rankings. The ranking points are to smooth out the schedule so that you aren't super in your final ranking at the tournament isn't super influenced by your schedule. You can have more control over it. If your opponents can directly defend a ranking point, that's a bad thing. Best robot, 1323 was one of them. Swerve Drive, the cargo went from one side of the robot to the other. Very fast elevator, extremely well driven. When I'm talking about best robots, it's hard to pick out individually what led to their on-field success. It can be genius in conception of design, execution of it, driving and match strategy and programming and all of these things. And it's very difficult to tell from the outside. But the best ones have a great combination of that. 1323 danced around the field. It was very fun to watch. This was the first year of brushless motors. The Neos came out. They're better than brushed motors. So is a good thing to start adopting that. So 971 this year, their robot, suction. So they use suction to hold on to both the hatch panel and the cargo. And this thin elevator went up and down, and the game piece manipulator could go up and over the top of it. And this meant that they could score on both sides of the robot pretty well. They made a small robot so that other teams could get onto the hab at the end of the match next to them, and they had a thing to climb up onto that. And the way that they drove evoked like a small child running around with a balloon over their head. So much fun to watch this robot. Very hard to defend because all right, so you're pushing me. I'm a smaller robot. You're pushing me in one direction. Fine, I'll just move my scoring thing to the other side and score in the thing that's next to me. Because the cargo ship was opposite the rocket ship. So as long as there were places to score, it is difficult to defend a robot that could score on both sides. And I highlight 1619 because there wasn't a shape or an object to hold on to this year. But there was a big flat surface upon which you could apply suction. And if they'd let us do it if it were legal this year with the charge station, oh, you better believe we'd be doing it. Because up to a certain amount of time after the match, it's up to like a minute that they could hang on without motor power. It was still attached enough, but not so attached that they couldn't take it off. But this let you do cantilever stuff, like hanging off the side of the hab platform, leaving a lot of space for your partners. I like both of these robots because of the vacuum thing. Our 190's 2008 robot also used a vacuum, though a very different system. It wasn't a series of pumps, it was just an impeller. But if you can get the suction part of your robot onto the thing that you're trying to get, that's the difficulty. That's what just roller bars or wheels are really good at, is you barely need to touch them and then the object starts coming toward you. But suction, once you got the thing there, you can hold on to anything. It's great. Whole robots hang off of that. But 2019, that was the last time that you could really be out here running the tank drive, the skid steer, West Coast drive, whatever you want to call it. Motor, you could use up to a certain number of motors for many of these years, and the more modern rules are just these are the legal motors, use as many as you want. And so motor choice was a bigger part of the engineering challenge in previous years. ThriftyBot and AndyMark and Vex and West Coast Products and whoever else is making more mechanisms, more systems. So you used to have to design everything together mechanically. You had to figure out gearboxes and linkages and bearing blocks for elevators and all these things. And some of that is kind of rote after a certain point. And drivetrains especially. So the rules loosened and companies moved into these open restrictions to get more teams with a robot that drives around on the field and does stuff. And then you can really do the fun part of robotics. And as more and more district champs started popping up and they went to 2 championships, I've been to every championship since 2006 except for 2017 Houston. Every championship has 400 plus teams. It's just a ton of teams out there, and it's really fun to see all of them. But at the peak in 2017 and 18, just had a huge number of teams going to championships, and then when they pared it back down to 1, that was when it was really wonky your advancement, because you to get fewer teams to championship than a year previous. So 2020 Infinite Recharge. I have a separate presentation that I'm working on about this game and how great a game design it is. So high goal. So it's like 2006. It's like aim high again. There's a high goal at the end of the field that you're shooting squishy balls into. The difference is there's an outer port and an inner port. In these structures, there's kind of the big goal, and it's worth a certain number of points. And there's a smaller goal recessed back in there. And if you get it in that smaller goal, it's worth more points. So as you're trying to get better at scoring in the high goal, you're still getting rewarded for your efforts. It's genius game design. So you could hold up to 5 of the power cells. These were smaller than the boulders, but they're the same dodgeball squish things. And you had your protected scoring zone, this trench. When you were in there, your opponents couldn't touch you, and you had your protected, and your little very small triangle in front, like right under your ports that you were shooting into, and where you collected the balls. So in these games where the game pieces get recycled, you're shooting at your opponents, and then their human players return them to the field. So at very high level matches, it's this balance. As you're scoring, your opponents are getting more ammo to shoot with. Early matches, if one alliance is way better than the other, then one side of the field just has a ton of game pieces that this game and games before it, you are forced to return a certain number of the game pieces to the field. But it's hard to get that balance right. And the other aspect, so there are 2 other aspects to this game. There's the color wheel, which is this thing on top of the table on top of the trench. And you can spin that, like the DJ, as it were. And there was a color sensor looking down. So after a certain number of power cells were scored in the goals, it would then let you spin the color wheel 3 times for bonus points. And then after more balls on top of that were scored, then you could turn it to a certain color, and that was worth more bonus points. And doing this sequence got you 1 of the ranking points. So there was a lot of steps to get to that. The other one was if you had enough hanging points at the end of the match. So this huge truss structure in the middle of the field held 2 coat hangers with bars across the bottom that you could hang from. And they were held in a central pivot so the whole thing could rotate. And you could have up to 3 robots in that rendezvous point trying to climb all at once. And this was also very good because it looked difficult. There's this unfully supported, unfully constrained thing that you're putting up hooks or whatever up to, and you're trying to coordinate with your partners to pull down because you got more points if the whole thing was level at the end. But in practice, if you put something up there, if you had a thing that motorized or whatever went up there and then you winched it down, if you got 3 robots on there, it was pretty much level. So it was easier than it looked. You just had to have an active mechanism to do it. But circumstances outside of everybody's control meant that this was the game that we had for 2 years. In 2021, in unfortunately vain hopes that they would be able to have in-person competitions that teams could go to, they modified the rules of 2020. It said, we're not putting out an entirely new game. The chances of there being in-person competitions is so low. But if there is, we're going to clean up some stuff. So the rendezvous point, this central thing, each division there is divided by the berms, the same metal, like the steel tubes that are powder coated, and those just destroy your wheels, and they just had a ton of them in there. So in 2021, when they did a refresh of the game, they took some of those out, so it's less bumpy. And they changed the threshold values for the different parts of the color wheel aspect of it. Cleaned the game up a little bit, but I still think we only got to see 2 weeks of it. So we don't really know what the game would have looked like. And we also don't know which the best teams were. But 5 game pieces is kind of an interesting balance of, well, you can keep them all in single file, or you can have a more fluid, like conceptually beautiful way of controlling all of these game pieces. So many different designs to get to. Now we're really getting into high fidelity control of turreted shooters. So most previous shooting games, you had a couple of places that you could shoot from, 1, maybe 2, that you were very happy with balls. This is a year where a lot of teams that were good in 2020 had fine control over their flywheel shooters. So you could shoot from many places on the field. And so then you had to have a good vision system because you could shoot from many places on the field. You weren't indexing to a physical thing. So 118 had a cool turreted shooter thing, and they had this big tracked thing was the best way to control the color wheel. I mean, it didn't come up that often because they only ran 2 weeks of it, but everybody who actually saw this in action said, oh, we have to put that on. It's so much better than what we have. Spindexer's like 148's thing had some eldritch mechanism in the center that the balls went into, and they spun around, and they didn't spin around once to get into the thing. They could just keep spinning, and somehow at some point something would kick them up into the shooter. We saw a lot of examples of that, but we didn't see the most sophisticated control of it. So it is now an option, another tool in the toolbox for teams to try to take advantage of is this concept of a spindexer. But this is also where we saw a couple of teams able to do this. This is 2056. They never competed on the field, but when I was a junior in high school, my lead mentor loved the idea in Aim High of being able to shoot while firing or move while driving, which is him trying to say shoot while moving or fire while driving, but he would keep saying it. The ability to actually feed forward and control things well enough to, this is 2056 on a bunch of pneumatic tank drive tires, shooting while strafing across the field. So they went with a lot of the other teams that I used examples of for this year. They all could go under that trench. 2056 said, instead of dealing with all these protected zones, we're just going to make it so that you can't defend us. We're going to be in the front. We're going to go over the rendezvous. We're just going to bounce over that thing like crazy. And then you're going to try to defend us, and we'll just drive next to you and score in the high goal. Very, very cool. I would have loved to see this game. 2022, Rapid React. We're back in it. We've got the high goal, the upper hub and the lower hub of a central structure that just recycles balls right there back out onto the field. And the balls, the game pieces for this year. Big tennis balls. Finally, a game piece that is mostly spherical, that survives anything. All of the poof balls and the basketballs and the boulders and the power cells, you would eventually, with your shooter, just tear a huge chunk out of those things. Just gone. These giant tennis balls could survive so much more. They were so even the variations between balls so much less than other years, even though they still existed. Fantastic game piece. So the rule, I say fixed 2013 endgame climb. The rule with the pyramid in Ultimate Ascent was you could only touch 2 levels at a time. If you were touching the first level, you couldn't touch the third level. If you were touching the second level, you couldn't touch the floor. So that sequencing that to make it actually work, very difficult. But it was a series of bars that you would go up. And the end game for Rapid React was a series of bars that you would go up to get to the So they had 4 bars: the low, mid, high, and traversal. How can you have a mid bar that's the second out of 4? Anyway, you could get up to the top, and it was worth a lot of points. And ranking points associated with a certain number of points in the end game that more than one robot had to get. The other ranking point you could get was just a whole bunch of balls scored in the central thing. And you started around the hub, and there were 12 cargo, they called them cargo, the tennis balls. 12 cargo arranged in an irregular dodecagon around this thing. And what it worked out to be is that you needed one robot that could score one ball that they started with, and then drive out of the tarmac, which was your starting area. And you had another robot that had to score the one ball that they had and pick up this ball, if you were red. Pick up this ball and score it. And the other one had to start and go and pick up these other 4 that you could get. So you get a 5-ball auto, a 2-ball auto, and a 1-ball auto. This was a low skill cap for autonomous relative to other years. Lots and lots of good teams had the best auto by the time they got to week 1. They might have made minor changes to it to get better consistency, but they were able to score like the maximum number of points that they were going to score in auto in week 1. And a very dynamic game because they just returned from this thing in quasi-random whatever. So there were no protected pickup zones. You just had to keep roaming around the field picking stuff up. It was like 2009 in that way. You just had to keep going around and keep shooting and keep shooting and keep shooting in very short like time cycles from pickup to delivery. So teams shot from a lot of different ranges. And this was, this really cemented you really want, if you have a flywheel shooter, to have a top and a bottom roller. So you have fine control over the two speeds that you're introducing to the ball as it leaves your robot. This is how teams were able to eliminate or reduce the number of bounce outs, because you could just hit the spinning wheel in the center and just bounce right out of the funnel. And so if you had a ton of backspin, it would tend to do that more. So you kind of wanted to throw knuckleballs into there. Best robots were Swerve and a turret, or Swerve and a very, very, very good vision lock on to the hub mechanism. And a lot of robots had the ability, you could control 2 game pieces at a time, or 3 for up to 3 seconds. And you could control your opponent's game pieces. So lots of teams sifted them. As they were driving around, they'd just pick up whatever. And they would keep their game pieces and they would just throw away their opponents somewhere else, out of maybe the shooter just shooting away from the hub, or just an entirely different exit point of it. But similar to that 2056 video, we see in 1690 Orbit's reveal video this ability to you just drive in a straight line and the robot does the thing. So cool to watch these. And when it comes to passing from bar over bar, some teams who had a really high fidelity practice field or structure to climb on when they were conceptualizing and making their robot were able to react against different things than just the rungs that were the places you scored on. So 254 and 1690 both reacted against the truss itself to allow them to not have to touch each bar on their way up. But like another robot, 1678, no turret. They just had the way of sifting through balls, and they did a hand-over-hand climber. But takes all kinds. But takes all kinds with the caveat that everybody was Swerve. There were 2 robots on Einstein with 6 alliances. 2 robots that didn't have Swerve. One of them had a turret, one of them didn't. But the availability and efficacy of commercial off-the-shelf Swerve and the unlimited number of high-powered motors mean that it's easier to put together a drive base that can go anywhere than it used to be to put a drive base together that can drive in one direction, in one vector. 2023, charged up. You drive across the field and you pick stuff up, and you drive toward yourself and you drop stuff off. That's it. 2023, 2 game pieces, a cube and a cone. The small rubberized, so they were both very small. A lot you had the fuel, which was like a 5-inch diameter ball. That was very small, but you had a ton of them, so you could see the stream of it going. The trackballs were 40 inches that year. In 2000, in aerial assist in 2014, they were 30 something. They were like 30 inches. These big game pieces all these years, and visually, it's a little stark when you look at Charge It Up, and you've just these tiny, tiny little things that you have to keep track of. Both of the game pieces were of similar size. One of them was an inflatable cube, which was a ball with corners on it. And the other was a rubber cone that was actually seriously fun to work with. And you could get a ranking point for having enough of the game pieces scored in a different array on the grid in front of you. There were 27 places to score up until championships. After everybody had played all their qualifying, after all their qualifying tournaments, the game design committee changed the game to increase the number of links, the different arrays that you needed to score the ranking point in qualifications, and they allowed for double scoring. Previously, if you scored 2 game pieces in a node in one of the places you could score, it was worth no extra points. But then at championships, it was worth just a flat 3-point bonus. And in autonomous, every game piece you scored was worth a flat 1-point bonus, regardless of whether you scored it on the top, middle, or bottom. These incentivize different things. Like in 2011 with Logomotion, the autonomous game pieces were worth more if you scored them higher. In 2012, same thing. The higher balls were worth, everything was worth double. So you got a higher delta of point values from doing stuff in autonomous. So between the flat bonus in autonomous and then the later addition of the ability to supercharge those nodes by adding an extra game piece into them, the bonus for actually doing stuff in autonomous and charged up is very low. And in 2022, we just looked at Rapid React. There were 8 game pieces that your alliance could score. In 2023, there were 7. It's just, it's a low cap. It was harder. You had to more precisely drive and do certain things between just those 2 games. But in 2006, in Aim High, 3 robots could each start with 10 game pieces. Each ball scored in the top goal in 2006 was 3 points, and then you got a 10-point bonus on top of it. We're not playing the game of what if we played like these old FRC games with modern things. It's a whole bunch of stuff would have to change because you'd have these autonomous modes in Aim High with like 90 to 100 points, just everybody scoring in the top. And that is not what happened that year. Teams did not score like that. So the other aspect of this game, big protected zones, your community, your opponents couldn't go in there and collect stuff with elements of their robot that extended outside of their frame perimeter, and they couldn't touch you. And same thing with these loading zones. And again, a mirrored field. So these 2 loading zones are right next to each other. So offensive robots are going in and coming out of these things on the same guardrail of the side of the field. The other aspect of the game was another teeter-totter. So kind of a re-up of the 2012 bridges that they had. But these have ramps, so you can just drive directly onto them without a mechanism to tip it down toward you. And you would get, in autonomous, you would get value for driving onto it and not touching anything else, and you would get points on top of that if it was also level. And then in the end, it's up to 1 robot in autonomous could do that. And then in the end game, you could have 1, 2, or 3 robots, either level or not level, different point values. So triple climbs eventually became a thing that you had to have because your opponents would have them. Climbs, going up the charge station, however you want to call it, like it's the end game thing. Best robot. We saw a bunch. So the thing that really threw everybody for a loop in 2023 was, as I've shown with a lot of the robots that I've chosen to highlight, the last game where arms were definitely the answer was 2005. All the other pick and place games since then elevators have had a lot of advantages. You don't need to reach that far. You just need to go up. And so you get to do a lot of linear motion. You don't have to do a lot of weird kinematics things. But some teams in some of those elevator years chose to do arms. And in 2018, Team 971 made what we now refer to as the Spartan arm, which is this very strange cable-driven thing that 176 made an example of this year. Carbon fiber round tubes make it so that you can have high pivot points and things that extend out very far with extremely light materials. So you're able to do fine control over stuff that you're holding very far away from your robot base. It was a very strange decision to do that in 2018, but a lot of teams reaped the benefits of that in 2023. Totally appropriate for this game. And another robot archetype that we saw was a lot of fixed tilted elevators. So just like all the other elevators, just instead of having it go straight up and down, you just put it onto your robot kind of slanted, and then it does all the things. This was the only year, likely, well, whatever, for the foreseeable, that we ever saw somebody put 8 drive motors onto a swerve drive. 4414 out there with that 12 motor swerve with that maximum weight robot. Really getting that kind of acceleration and top speed. This year's game with the field, you're doing these huge, super long cycles. All these fields are 50 feet long. So then it really, a lot of the difference between the top teams is how fast can you drive. Because all of the top teams can manipulate game pieces quite well and score them well, but then what's the thing that's left to make the difference? And it's drive gearing, and it's just going super, super, super fast and killing your batteries. But there were a lot of examples of robots that took the architecture of what Team 233 and other teams before them, but everybody calls it the pink arm because that was like the best one for a lot of the years they did it. A very low pivot arm with an extension, a linear extension within it, with most of the time just one set of nested tubes. Technically a little bit hard to control, and back in the day everything just ran super slowly, so it was fine. But with fast stuff, it's an interesting motion to have to deal with. But a lot of good examples that we saw that year. So this, a little bit of a bonus thing. 2023, when it comes to the design of the game, seems to have missed a lot of the, like, when we saw these games played, we learned, oh, this doesn't work. Like, this aspect of this game makes it so that it really isn't very robust at the highest levels. So 2011, because the lowest row that you could score on was worth only a certain number of points that couldn't make the difference in high-level matches, you have alliances that just didn't fill the thing, because even if they scored those extra game pieces, it wouldn't make a difference. But more importantly, 2019, you had 36 places to score. Each successive game that has a fixed number of places to score should have a higher number of places to score, because we maxed out 2023, and we maxed out 2023 before championships, before the highest levels of play, so badly that they had to invoke a clause in the rules that used to be in the rules and isn't anymore. From 2000, it was prevalent in like 2016 era, a couple of the years around there. It said, when it described the point values for things, that later in the season the GDC might change the threshold that it takes to get these bonuses, these ranking points, these things. That clause left the rules after a certain number of years, and it isn't in the rules, in the printed rules in 2023. But the game was not going to work at championships, especially with the huge number of potential penalties, because you're trying to push the bleeding edge, and you're going right next to these very, very high leverage protected zones. If championships happened without the rule change that they made for 2023 charged up, it would have been decided by fouls and robots breaking and differences in autonomous points. Everybody would have been able to fill the grid. Every championship contending alliance would have been able to fill the grid. So then it would have come down to, you really need to pick an alliance that can do that and triple balance. So everybody would have been able to triple balance, and an alliance that actually gets all the autonomous points, because then you can get that perfect 193 for this game. There was a points cap that you could just calculate. And so then the only difference would be, would your opponents earn fouls? Would your opponents miss autonomous points? Would somebody break? And so that is a very fragile game in that way. Another thing that is really good in a lot of these games is, if you're trying to do everything, you have to make decisions to trade off some capability in one area, or if not capability, then you have to pour a lot of resources into having these parallel things. So the two aspects of this game were manipulating and driving the game pieces across the field to do cycles, and the other one was the end game and the autonomous thing of the charge station. But we saw some reverse buddy climb sort of things, forks that went under other robots that you could leverage, that you could lever your robot off the carpet with. So it could be balanced with your two partners, and you could come in at the end, or you could drive up the side, or a couple other things. But instead of developing any mechanism at all, you could have three robots just drive up the charge station next to each other. And what's more, you didn't need to make your robot especially narrow to do that, like you had to in 2019 with the HAB. If you wanted to get a bunch of robots up top there, either you had to have this weird cantilevered suction or other forks thing, or one of your robots had to be like really teeny tiny, and that made the rest of it made it more difficult to develop the mechanical systems on their robot. It made it more difficult to drive. It's a small, weird, tiny drive base. But everybody just had a regular sized drive base this year, and you just all went up next to each other. So no trade-offs to be able to perform at the absolute maximum level. And because it's just full speed everything, we saw full speed collisions. And even in 2017, when the field was also mirrored and your aim was to drive across the field in paths that did cross, robots drove about half as fast in 2017, a little over half as fast. So you have twice the energy going into these collisions. So you're just asking for trouble. In terms of game pieces, the cubes were balls that were worse. Like the power cells in 2020 and 2021 in Infinite Recharge were pretty okay. I mean, you can drive over those poof balls and they just get stuck under your drivetrain. Sometimes you're stranded for the entire match. And you can tear pieces out of them, and they're sort of inconsistent, and there are problems with them. 2022 Rapid React, those tennis balls are great, and they survive a lot of things, but they're still, they're quasi-oblate spheroids. They're not exactly spheres. They're these things. But the cube, I mean, it's an inflatable game piece, like the 2007 or the 2011 inflatable toroids that they used those years. And those just pop. You just make a tiny hole in them, and it's very easy to do that with any part of your robot. And yes, you're supposed to not have stuff that breaks the field and cuts these things and no sharp edges and all of this stuff, but those happen. Pinch points happen. And so very, very, very fragile game pieces they really don't make sense. And you drill down further into what 2023 Charged Up was doing. The autonomous bonus for getting on the charge station was either 8 or 12 points. But the threshold that you needed to get over to get the activation bonus, the bonus ranking point for doing the charge station stuff during the match, was 26 points. So you could get that with either a dock or an engage in auto, and then a double balance. It didn't matter whether you docked or engaged in auto. That would not change what you needed to do in the end game to do it. So just different incentives for like actually performing at a higher level have to be more explicitly rewarded for teams to really be able to focus their design and their design overall strategy and their match strategy to take advantage of actual things that are different between what they're able to do and what their opponents are able to do and what the field asks of them. And sight lines were terrible. So yes, a completely open field. You could see everything that was on the field except the place that you were scoring, because it was directly in front of the opaque player station that you were in front of, and there were structures in the way. So you had to lean around the side of the Alliance station wall, but not past the tape line that they had to put down, because the line kind of extends where you can walk out to, but you had to keep checking these things. It was very difficult to see where you scored during the match if you were a driver or a coach. And it was difficult for scouts to see where people scored during the match. One of the tenets of like game design that a lot of people cite is you should be able to see who's winning just by looking at the match. And some games that really doesn't work for. I mean, a lot of the games that I really like, the high goal shooting, recycling game piece games, they don't necessarily have that. But if you watch for a little bit, you get a sense of, it looks like this alliance is scoring more rapidly than this alliance. And so that's not like a hard and fast rule to go by, but if you completely fail at that, by that measure, it should give you, I think, a little bit more pause. And something that we've seen a trend with is to really get your robot to the absolute maximum levels. You want to be designing and testing it with a very, very high fidelity recreation of the field. And so there were differences between the team version and the field version of all of these structures in all of these years. Like 2022, the rungs that were on the climbing structure in the home version were a thicker, more less pliant steel tube, and the ones on the field just shook more. And you also, not everybody was out here like renting actual theater truss, so you didn't have all of the elements. But this year, the charge station, for a structure that asked so little of you in terms of design trade-offs and like what it takes to do this, because you achieved the end game by using the drivetrain that you already had to drive around the field with. For that, you had to make an incredibly complex structure that had no design goal, that had no calibration goals. Like, how much force does it take to tip the charge station in one direction? Was not an answer that was available. It was available for the 2012 bridges, but it wasn't this year. And it's a very complex, welded and polycarbonate and sheet metal, all sorts of things. I know teams that made it this year, that made as close as they could to the real charge station structure, that spent $8,000 to do it for an end game where the challenge was drive. Anyway, I don't like 2023, and it's 2100, so I'm going to call it. If you have questions, if you're watching this recording, or if any of you are watching live, you poor people who have had to suffer through this, you can just ask me. I'm always up for talking about any of these games. I'll point you to matches that were really fun to watch, or sequences of matches that really show off the best of those games. Or I have this presentation wasn't really about anecdotes, but just a whole bunch of fun stories from every team. If you have the chance, watch the 2015 Robo League documentary that Team Rembrandt's put out. It follows a few teams at the 2015 championships. Very rewarding. I love to see the stories of these teams. And the new Cool book by Neil Bascombe about one team in particular's season from 2009, like an outsider's perspective with an embedded reporter on an interesting team from that year, 1717 DePenguineers. Really like an unvarnished look at like a build season and a competition season for a team that is really striving for like the top levels. Fantastic book to read. Yeah. Thanks everybody. And then let's kill it.